Hello everybody. So in this video we are going to discuss some more questions on trigonometric ratios of allied angles which we were discussing in the previous video, and then we will be discussing some logic behind that thing as well. So let's start with it. So for example, somebody is saying, what is this? Cos 360 minus theta. What is this thing? So for that thing, the shortcut which we discussed in the previous class along with the logic, you have to remember this ASTC rule as well. All school to college. So you start from here in the anti-clockwise direction. This is 0 degree. So this will be 90 degrees and so on. This will be 180 plus 90 is 180 plus 90 is 270. And then you keep on going like that. This will be 360. And then if you add 90 in it, this will be 450 and so on. If you add 90 to it, this will be 540 as well and so on. It will keep on going, right? So now you see the angle is 360 minus theta. 360 minus theta is in which quadrant, guys? You see, if you make one complete revolution, that is 360 degrees, right? Minus theta means you're over here. You're basically in the fourth quadrant, first, second, third, fourth. In the fourth quadrant, C for cos and its reciprocal sec will be positive and all other trigonometric ratios will be negative. It means this will be positive. That is the first thing. Now when the reference is horizontal, means when the reference is these angles, right? The trigonometric ratio will not change. Cos will remain cos only. So therefore that is equal to cos theta only. I hope that is clear. Now suppose in the same thing, suppose I ask what is the value of sec 90 plus theta, suppose they ask, right? So again you have to see that 90 plus theta is in which quadrant. So 90 degrees plus theta, you are in the second quadrant. So in the second quadrant, S for sine and its reciprocal cosec will be positive and all other trigonometric ratios will be negative. So over here the answer will be negative, correct? Now when the reference is vertical, that is 90, 270 and these angles, then trigonometric ratio will change to its co-function. I was discussing in the previous class. So sec will change to cosec. So the answer will be minus cosec theta. So the answer will be minus cosec theta. What are the co-functions? You see sine, cos, sec, cosec, and then you have got tan, cot. These are the co-functions over here. Means sine will change to cos, cos will change to sine, sec to cosec and cosec to sec, tan to cot and cot to tan. If you have got the reference as the vertical. I hope that is clear. In the same manner, suppose I give you another example. For example, it is, suppose they are saying sine 270 plus theta. Suppose something like this you have got. So you have to see this angle is in which quadrant. You see, you start from this is 270 plus theta means you are in the fourth quadrant. In the fourth quadrant only C for cos and its reciprocal sec will be positive and all other trigonometric ratios will be negative. So the answer will be negative. And when the reference is vertical, 270 degrees vertical, so sine will change to its co-function, that is cos. So cos theta, minus cos theta. So that's how it is done, guys, right? Now let's do a couple of questions on the basis of this. For example, we have got 1 plus cos theta upon 1 minus cos theta over here inside the square root, and it is given that it is equal to cosec plus cot. Then theta is in which quadrant? You have to see over here that theta is in which quadrant. So for that thing, let's simplify this thing first inside the square root. You see, that is 1 plus cos theta upon 1 minus cos theta. So you see, this is 1 minus cos theta. Can I multiply and divide by 1 plus cos theta? So that it will be fixed in the formula, right? So this is nothing but square root of 1 plus cos theta the whole square. And in the denominator, what will you get, guys? 1 minus cos, 1 plus cos. So 1 minus cos, 1 plus cos will be 1 square minus cos square theta. A square minus B square identity, right? Now this is nothing but 1 plus cos theta upon 1 minus cos square theta is sine square theta. So that is sine theta the whole square, right? See over here. Now basically you know this logic that square root of x square is never equal to x. I did explain it many times on this channel that square root of x square is modulus of x, and I did explain the logic behind it as well. So over here this will be 1 plus cos theta upon sine theta and modulus of it, correct? Now if you just separate it out, this is 1 plus cos theta modulus of it, and in the denominator it is sine theta modulus of it. Now understand one thing, guys, cos theta, this cos theta, the minimum value is minus 1 and maximum value is 1. You know the value of cos theta and sine theta. The minimum value of cos theta and sine theta is minus 1 and maximum value is 1. So what does it mean? Even if this is minimum, the overall value will be 0, and even if it is maximum, the overall value is 2, right? You see 1 minus 1 is 0 and 1 plus 1 is 2. So what does it mean? The modulus will open as it is. That will be 1 plus cos theta as it is. You don't have to bother about it, right? Because you know the definition of modulus. Modulus of x is equal to x when x is greater than or equal to 0. It is minus x when x is negative. See this, when x is negative. So, and the equal to thing can be in both of them, right? Equal to thing can be in both of them. You know that modulus of 0 is equal to 0 only, right? But in the denominator, you see it is only sine. So it will open up equal to only sine theta. It will open up equal to only sine theta when you know that sine theta is positive. See, the denominator can't be 0. So it will be equal to sine theta only when the denominator is positive. It means as per this question, sine theta is greater than 0. Why? Because if you separate this out, this is nothing but 1 by sine theta. This is 1 by sine theta plus cos theta by sine theta. See this thing. So 1 by sine is what? Cosec, and cos by sine is sec. And it is cos by sine is cot. So it is given equal to cosec plus cot, right? It means you are taking modulus of sine theta equal to sine theta only. And that is only possible when sine theta is greater than 0, right? Now you remember this logic, ASTC rule. ASTC rule. That sine theta is positive, all school to college. In the first quadrant, when the angle is in the first quadrant between 0 and 90 degrees, then all the trigonometric ratios will have positive values. And when the angle is in between 90 degrees and 180 degrees, that is in the second quadrant, then as for sine and its reciprocal cosec will be positive. Now over here, sine is positive means the angle can be in this quadrant or in this quadrant. That is first or second quadrant. So first option is correct. I hope that logic is clear. Right. Now let's do a similar type of question over here. I mean, not similar, but on the basis of that allied angles concept only, allied angles or allied angles, whatever you may pronounce. So you see, tan 20 is given lambda over here. We have to find the value of this expression. So I did discuss this in the previous video as well, that try to write these things close to these angles, the angles along the axis. You see, this is 0, 360. If you make one complete revolution, it is 360 as well. This is 90, this is 180, and this is 270 degrees. Correct? And you remember this ASTC rule, all school to college rule. Correct? Now if you take tan 250, if I take this one, So can I write it like this? You have to write around closer to these angles. Then only you can do some kind of simplification. Otherwise, it's not possible. So I can write it like this, 270 minus 20. Correct? Fine. Now this is 270 degrees. From here, if you start, that is 270. Now minus 20 means you are in the third quadrant. Minus 20 means you are in the third quadrant. In the third quadrant, T for tan is positive and all other trigonometric ratios will be negative. So that is positive. Now the reference is vertical. Reference is vertical. So tan will change to its co-function. So cot 20. That is plus cot 20. Correct? And then tan 340 over here. If I take tan 340, what is that? I can write it like this, tan 360 minus 20. Now 360 minus 20 is in which quadrant? It is in the fourth quadrant. And in the fourth quadrant, only C for cos and its reciprocal sec will be positive and all other trigonometric ratios are negative. So that will come out to be negative. And when the reference is horizontal, trigonometric ratio will not change. So minus tan 20. Now over here, this is tan 200. That can be written like this, 180 plus 20. So you see 180 plus 20 is in which quadrant? It is in the third quadrant. 180 plus 20. In the third quadrant, T for tan is positive, right? So that is positive. And when the reference is horizontal, trigonometric ratio will not change. So that is tan 20 only. In the same manner, if I take the last one minus, or you can directly write tan 110, I can think of it like this, tan 90 plus 20. So it is in which quadrant, guys? 90. This is 90 plus 20. In the second quadrant, only S for sine and its reciprocal cosec will be positive and all other trigonometric ratios are negative. So the answer will be negative. And when the reference is vertical, tan will change to its co-function cot. So cot 20 over here, minus cot 20, right? So you see, just put the values over here, guys. You see tan 20 is lambda. So cot 20 will be 1 by lambda. This will be minus lambda. This will be plus lambda. This will be minus 1 by lambda. That's it. Then you just have to plug in the values over there and then you have to simplify. So you see tan 250 is what? Maybe I'll put it over here itself. See that, guys. So tan 250 over here, we are getting 1 by lambda. So just put it over here, 1 by lambda. And then 340 over here is minus lambda. So minus lambda. And in the denominator, tan 200 over here, we have got lambda only. That is lambda. Let's put it. And then minus is there. Tan 110 we have got equal to minus 1 by lambda. Minus 1 by lambda. So if you simplify it, what will you get? You see that is 1 minus lambda square. And in the denominator, you'll get lambda square plus 1. Because lambda from the denominator will be cancelled out. So the answer is 1 minus lambda square upon 1 plus lambda square. Second option is correct. You can check it obviously. So that's the logic for it. Obviously, you can think of it orally as well, but I'm explaining everything. Therefore, I have to write for you in case you don't understand that orally. So let's move on to the logic part of it, that why it is actually working. So I'll take one reason for that. I mean, one example for that, and I hope you will get it for sure. See this, guys. So let's go back to the unit circle for that. If you remember in the previous session, I was explaining this unit circle logic. So you have got the unit circle over here, right? Unit circle means a circle of 1 unit radius. Suppose I'm taking a random angle theta and the corresponding x coordinate and y coordinate I can take over here, right? And then I can drop perpendicular on it. So you see this will be x and this will be y, and if it is unit circle means this is 1. Correct? So over here, although we did it in the previous session, but if you find sine theta over there, what is that? Sine theta is perpendicular upon hypotenuse. So that is y over here. So cos theta is what? Base upon hypotenuse, that is x coordinate over here. Although I did discuss over here in the previous video that for any point on this unit circle, the x coordinate is the cos of the corresponding angle and y coordinate is the sine of that corresponding angle. Correct? So over here, suppose they are telling us to find the value of sine 90 plus theta. Suppose sine 90 plus theta, and then they are saying to find cos 90 plus theta. See that thing patiently, right? So this angle is theta. I want 90 more. So I have to rotate this thing, guys, to like this it will become. So if you take 90 over here, this total angle will be what? This angle will be 90 plus theta. I hope you understand that. This angle will be 90 plus theta over here. And then you understand very logically. See, this base will go over here. So you'll get, and then this thing will come over here. The base will come over here and this will come over here. So this thing is equal to x. See this. So over here, this will be equal to x. Correct? And this is y, means this will be equal to y. See this very patiently. Correct? This is y. So the coordinates of this point will be what? Because it is in the second quadrant. So that will be minus y comma x. See this. Minus y comma x. Now what did I say? The x coordinate. This is the x coordinate now. It is the value of cos. So cos 90 plus theta is equal to minus y over here. It is equal to minus y over here. And you see y was equal to sine theta. So can't we say cos 90 plus theta is minus sine theta? Have we proved it? In the same manner, sine 90 plus theta is equal to the y coordinate. So that is equal to x. But you see x was equal to cos theta in the first case. So have we proved that sine 90 plus theta is cos theta and cos 90 plus theta is sine theta? So it is working as per the logic as well, which I was explaining, the method that the angle is in the second quadrant 90 plus theta. So you remember ASTC rule. ASTC rule. So in the second quadrant, S for sine and its reciprocal cosec will be positive. So that is positive. And when the reference is vertical, 90 degree, sine will change to cos. So you see that is working. And this is the logic for that thing. So that's all we needed to discuss over here, guys. In the same manner, you can think for other angles as well. 180 plus theta, 180 minus theta, 270 plus minus theta, 360 plus minus theta. Same type of logic will work, right? You can obviously work it out on your own as well. So that's all we needed to discuss over here, guys, on the Infinity Learn Class 9 and 10 YouTube channel. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel, and don't forget to subscribe to the Telegram channel as well, because whatever is being discussed in live sessions, you can get the PDF of those sessions as well. Bye bye guys, take care everybody.